In this video, we're going to be taking a look at solving equations in which the x appears on both sides of the equation. So like in this particular problem, you see that we have an x on the left and an x on the right. And that's going to be the big theme out of all of the problems that we look at here. And of course, you will see different variations about how that can show up as we go. All right, now whenever you see this type of situation, the very first thing you want to do is look to see if there's anything you can simplify on either side of the equation. So like I'd be looking at this 7x plus 8 and saying, is there anything I can simplify or combine there? And there isn't on that side because the 7x has an x in it and the 8 does not. Therefore, they are not like terms, and so we can't do anything there. Same thing on the right-hand side. You'll notice the 4x has the x in it, the 7 doesn't, so they can't combine. So there's no simplifying we can do first here, although you will find that that's going to be a big thing we do first in later problems. Now that I've checked that, I can go ahead and start solving. Now, what makes these different, of course, is the fact that x is on both sides of the equation. So let's next make it so that x is no longer on both sides of the equation. We are going to move x to be on the same side. Now, when you do that, you have a couple options. You could move the 7x to the right side, or you can move the 4x to the left side. Both of those are valid options, and both of them will get you to the correct answer. However, what I've found is that a lot of times, if we have a negative number multiplied by our x, we're more likely to make a mistake with that. And so for that reason, I personally will always try to keep my x term positive, which means I'll move the smaller one, which in this case is the 4x, to the other side. So if I'm going to move that 4x to the other side, notice that it's right now being connected to the 7 by subtraction. It's actually addition and subtraction. It's currently a positive 4x. So if I want to move the positive 4x to the other side, I'm going to need to subtract 4x from both sides. Now you might be saying, yeah, but I thought that since it's subtraction between the 4x and the 7, shouldn't we be undoing subtraction by adding it? Well, that would be true if we were moving the 7, because the 7 is actually what that minus is attached to. But because the 4x is positive, I have to be undoing the fact that it's positive. And so that's where we're subtracting. All right, now when I write my step here, and I write it on both sides, notice I line the x's up with the other x's. Specifically, you'll notice I did that over here. It doesn't actually change the meaning. You know, if I had written it instead over here, it still would mean the same thing. I'd still have to be doing the 7x minus the 4x because they're the like terms, but it just makes it a little bit easier to see. The reason is that technically we're starting by doing this, 7x plus 8 minus 4x, and then we're combining the like terms. But by writing it this way, we're just cutting that process short so you don't have to write that extra line. By writing it underneath, we take care of that. So let's go ahead and do the 7x minus 4x. 7 minus 4 is a positive 3, and so that's going to be 3x. Then the plus 8 stays the same, and then on the right side, remember we took out the 4x. Notice what's left behind. The minus is still in front of the 7. And so when I do that, then on the right side, I'm going to be left with negative 7. And now that we've done that, now the variable is only on one side of the equation, and now it's back to the familiar territory that we've worked with before of just moving everything that's not x out of that one side now. So I'm next going to subtract 8 from both sides. And so I have 3x equals negative 15. And then since I have 3 times x right now, and I want to get rid of the 3, I'm going to undo the multiplication by dividing both sides by 3. So on the left-hand side, that's going to give me x, and on the right-hand side, a negative divided by a positive is a negative, and 15 divided by 3 is 5. Therefore, x equals a negative 5. And that is our final answer for that one. And then we move on to our next problem. And looking at this one, it looks very much like the last one. So you might be thinking, oh yeah, easy, easy. However, this one has a wrinkle in it that I want to make sure you can see ahead of time and know how to handle. So first thing we want to do is look to see if we can simplify anything on either side before we start moving stuff from one side to the other. And you notice there's not anything. There's no like terms that we can combine here. And so I can go ahead and start moving stuff side to side. And I do like to move my x's first. It actually saves us a little bit of a headache later on, potentially, if we do. And I do like to keep my x term positive. So for that reason, I'm going to choose to move the 7x out of the right side and into the left side. So I'm going to take 7x away from 9x, which is going to leave me with 2x plus 4 equals 4. Now that I have the x only on one side, I can now just continue to get rid of everything that isn't x from that side. So I'm going to subtract 4 from that side. And of course, what I do to one side, I have to do to the other as well. And so that's going to leave me with 2x on the left. And on the right side, I have 4 minus 4. And 4 minus 4 equals 0. Now, what happens with this problem is I sometimes see people say, wait, 4 minus 4, it canceled out. There's nothing left. Well, you're right. There's nothing left. It's 0. But we actually do use the number 0. 0 is a number, and we can go ahead and continue working with it. And in fact, some people look at this and say, wait, what do I do from there? But I'm still trying to get the x by itself, right? Well, right now it's 2 times x, so let's divide by the 2. And you'll notice then that that means I'm going to be doing 0 divided by 2. Well, on the left side, that gives me x, and on the right side, 0 divided by 2 equals 0. And so that would actually be our final answer here, is that x equals 0. All right, now that one is done and complete, but I want to go back to the start and just show you something, okay? Because I do like to start by moving my x's first. I find that that makes life a little bit easier, but not everybody does that. Some people move their numbers first, and that still technically will work, but it can lead to some confusion. Because let's say instead you had started this problem by subtracting 4 from both sides. You then would have had an equation that said 9x equals 7x. And that's where people start scratching their head saying, what? Well, if you do find yourself in this situation, you still can continue solving it just like you normally would, except you would subtract the 7x from both sides in order to get all the x's on one side. And notice then you'd have 2x equals, and then 7x minus 7x would be 0. Notice that's exactly the same thing we wrote here. So yes, it still will work if you do it that way, but it just looks so wonky that a lot of people don't like doing that and would rather move the x's first for that reason. On our next problem here, you'll notice now there's a set of parentheses involved. So there is some simplifying we can do then at the start. Now, that's not going to be on the left side of this particular equation because 3x minus 6, there are no like terms there. So that's just going to stay at 3x minus 6. But on the right-hand side, I am going to distribute into the parentheses first in order to simplify. Now, just be very careful here. What number am I actually multiplying into my parentheses? Notice it's a negative 2. Keep the negative with it. All right, so I'm going to do negative 2 times x, which is going to give me negative 2x. And then I'm going to do negative 2 times a positive 8, which is a negative 16. And so I'm going to write that then as minus 16. Now this looks more familiar. It looks like the last couple of problems that we just did. And so once again, I'm going to try to get the x's both on the same side. And if I think ahead a step and think about which one will leave me with something positive, I can see that I want to move the negative 2x to the other side. A side note here, if you chose instead to move the 3x to the other side, it still would work. You just end up dividing by a negative at the end instead, but you would still end up with the same answer. All right, but I did decide I wanted to move the negative 2x to the other side. Now you'll notice I'm saying that I'm moving negative 2x. Well, if I then look to subtract 2x from that side, you notice that that does not equal 0. In order to get rid of a negative 2x, I have to add 2x, because then negative 2 plus 2 is 0, which is what we want. That makes it cancel out. And so I'm adding 2x to both sides. And so when I do that, I then have 5x minus 6 equals a negative 16. Because remember, that minus in front of the 16 is attached to that 16. All right, now then, I got the x all by itself on the left side. I just got to get rid of the 5 and the 6. So I'm going to start by getting rid of the subtraction. I'm going to add 6 to both sides. And so I have 5x equals negative 10. And then finally, to get the x by itself, I'm going to divide both sides by 5, which leaves me with x equals negative 2. And since I now have the x by itself on that left side, no other numbers over there with it, I got my final answer. In this next problem, you notice now I have multiple sets of parentheses, but our basic process is still going to be the same, where I'm just going to start by simplifying anything I can simplify. It just means that there's simplifying to be done on the left side and on the right side this time, instead of just one of them. So let's go ahead and start by getting rid of the parentheses on the left side. That means distributing the 6 into our parentheses, so 6x, then minus 12, because I multiplied both of those by 6. The plus 30, it's still hanging out there because I haven't done anything with it yet. On the right side, notice I have a negative in front of the parentheses. That means I'm distributing a negative 1 into both of those terms, which is going to leave me with a negative x minus 3. All right, you know, there's still some simplifying I can do here. You'll notice that I have this negative 12 plus 30. I can still combine like terms there. So let's go ahead and do that then before we do anything else. So the 6x stays the same, but I'm going to do negative 12 plus 30, which is a positive 18. Then that equals negative x minus 3. All right, now on the left side, is there anything else I can combine? No. On the right side, is there anything else I can combine? No. That means I can now go ahead and start moving stuff side to side in the equation. So notice I'm always finishing that simplification part first before I move stuff side to side. Now in this particular problem, I again want my x term to be positive. So it looks to me then that I'm going to be moving my negative x to the other side, because in order to move a negative x, I would be adding x to both sides. And I know that 6x plus x will be positive. Specifically, that's like 6x plus 1x. And so if I have 6 x's and I add one more x to it, it gives me 7x. So we now have 7x plus 18 equals a negative 3. And remember, it's a negative 3 because whatever sign is in front of the 3, that is, whatever sign is to the left of 3, it stays with it. All right, now I want to get rid of the 18, so I'm going to subtract 18 from both sides. So we have 7x equals negative 21. And then finally, I want to get rid of that 7, so I'm going to divide both sides by 7. And then that leaves me with x equals a negative 3 as my final answer. Once again, in this problem, you'll notice that there is some simplification that we can do on both sides of our equation. So I want to do that first. So I'm going to get rid of the parentheses on the left. Since they're adding, notice that that doesn't change what's inside the parentheses because I'm basically multiplying a 1 into both of them. So the left side is just 7x minus 4 plus 3x minus 1. On the right side, well, the first set of parentheses just isn't going to change because there's a positive 1 out front. But the second set will change because notice it's subtracting, which means we're multiplying a negative 1 into the parentheses. And therefore, it's going to be a minus x minus 3. If there's any one particular error that tends to crop up with these, It's that particular sign right there. All right, having done that, I now am going to go ahead and combine like terms on both sides. So on the left side, the 7x and the 3x are going to combine. So they become a 10x. And then our minus 4 and our minus 1 combine. So I have negative 4 minus 1, which is negative 5. On the right side, I'm going to do the same thing. There I have a 2x minus x. 2x minus x is 1x. I don't have to write the 1 out front. 1x is just x. And then I have the positive 7 and the negative 3. So I'm going to do 7 minus 3, which is a positive 4. And so I write plus 4. All right. Now there's no more simplification that I can do on the left or on the right. So I'm going to move all the x's to the same side. And so I'm going to move this x from the right side to the left side. And so 10x minus x gives me 9x. That's 9x minus 5 equals 4 still. Now I need to get rid of the minus 5 because I have the x on the left only. So I'm going to add 5 to both sides. The 9x is still there on the left, but on the right side, that now equals 9. And so the last thing I want to do is divide by this 9 so that I get the x by itself. And then that leaves me with x equals 1. And since I know what x equals, I'm done with that one. Now on our final problem that we're going to be looking at here, again, you notice there's a decent amount of simplification that we can do on both sides. That's all you're doing at the start. You're just going to simplify this left-hand side, so distribute into the parentheses and combine like terms, and you're going to simplify the right-hand side by distributing and combining like terms. And so we end up with this. Notice I distributed the 2 into this set of parentheses. I distributed a negative 6 into that set of parentheses. And then I distributed the 5 and the positive 8 as well. So now that we are here, we can go ahead and combine like terms on both the left side and the right side. And so on the left side, we end up with negative 4x plus 2. And on the right-hand side, we end up with 13x plus 19. Now, we want to move the x's so that they're both on the same side. And in this case, you'll notice that in order to keep the x term positive, I'm actually going to want to move it from left to right. All the problems that we did up to this point, I was moving the x from the right side to the left side in order to keep it positive. That was just chance. Sometimes it happens that way. But in this case, we're now going to be going from left to right. So that means I'm going to be adding the 4x to both sides. And again, I try to line the x's up with the x's when I write that underneath. On the left side, the 4x cancels it out, and so we're just left with a 2 on the left side. And then on the right side, we have 13 plus 4 is 17, so that's going to be 17x plus 19. All right, last thing is now that we have all the x's on the same side, now we get rid of all the numbers so that only the x remains. So let's go ahead and subtract the 19 from both sides. And you might be looking at that 17 thinking, boy, I hope this divides evenly. And you can see here, yes, it is going to divide out nicely because we're going to divide both sides by 17 here. And you see that that ends up giving us a negative 1 equals x. And we're done.